All right. Hi, everybody. I'm Andy Starks. I'm with Macnica. I'm also with Ames, the marketing working group chair, and I work with all the fun people at Ames and BSF and AMWA to help bring IPMX to life. I'm going to just kind of go over the basics of IPMX in this presentation and just talk a little bit about where we're at and the next steps as we kind of march towards standardization and the release of IPMX. I think this is the, wait, which one is it, the forward one? Okay. Let's see. All right, I think I got it. All right, so who makes IPMX? First, I'm just gonna kind of cover some of a little bit of the background. So IPMX is created really by 3 organizations, and then there's also SMPTE there, which is part of the underlying standards we'll talk about. But the 3 organizations, in order of the way I've got them listed here, Video Services Forum, that's where a lot of the transport layer, the core documents for IPMX are created. They're also the creators of, original creators of SMPTE 2110, used to be called TR03 and 4, and now you know it as SMPTE 2110, and that really is the underlying basis for IPMX, which I'll talk about a little bit more in a bit. But that's where the transport specifications come from. IPMX also includes a control layer, and that's covered by AMWA, and they're the creators of MMOS, and some of you may also know of a format called MXF. That's also from AMWA. And of course, Ames, the booth that you've got here, Ames manages IPMX as a technology, as a brand, and also provides a market insight and product management for IPMX. And then I wanted to mention SMPTE as well, because SMPTE is the standards organization that is part of, or has created SMPTE 2110, and also might also have a role in future portions of the IPMX standard as well. So IPMX is really the best way to think about it is it's an open standard AV over IP compatibility ecosystem. So it's not just a standard, it's not just a specification, but what we're trying to create is something akin to what you think about when you think of like Wi-Fi or USB, right? You can go and use all the standards for Wi-Fi, but you don't have a Wi-Fi device unless it's meets certain performance specifications, testing specifications. We want to create that a real high level interoperability ecosystem, and that's what IPMX is all about. That's what our goal is. Oh, okay. We'll go that route. Sorry about that. That's better. Where's Tina? Okay, here we go. So hopefully some of you heard a little bit about IPMX. This slide is actually pretty out of date, but we started about 3 years ago. We started really with SMPTE 2110 and MOS, plus all the things that Pro AV needs in the market, and we used to go around and talk about that. It got a little bit cumbersome, so we created the IPMX brand in February of 2020, and since then we've gotten a lot of press, have been talking about it a lot. We've gotten a lot of participation in from the industry, and I'll kind of talk a little bit about that until we are here today. So that's a little bit of the background. Now let's go into the basics of IPMX. I'm just going to kind of talk to each one of these little icons here briefly, and I've got a couple more slides on this. First, IPMX is based on established standards that are already defined in the broadcast market. So we started with SMPTE 2110 and MBOS. And if any of you guys are familiar with that, it's been around for, gosh, how many years now, Jack? About 10 years now. So if you've ever watched television, you've seen plenty of SMPTE 2110. It's basically the standard within broadcast, especially at scale. When you need a system that can scale the 10,000 channels across the world, SMPTE 2110 is going to be how you're going to do it. NMOS is also a huge part of IPMX. NMOS is an open standard specification for the control plane. So that's seeing a representation of your device on the network, being able to connect to that device and being able to configure it for playback or for sending video on a multicast network. And that's what NMOS is about. It's an HTTP protocol, and that's a big part of IPMX. Now, IPMX is not just one 1 gigabit standard or a 10 gigabit standard or anything like that. It's actually a set of profiles that include uncompressed and compressed video. And right now within VSF, we're working with JPEG XS. We're evaluating even other codecs, and especially we anticipate having a profile also for high compression, such as H264, 265. I don't want to announce any one of those codecs as a winner there, but those are the ones we are evaluating. But we're really targeting kind of upon the initial release, having an uncompressed and then a mezzanine format for basically 4K 60, 444 video over a 1 gig connection, perfect desktop quality. And then also high compression for Wi-Fi and that kind of use case. Security is a big part of IPMX on both the transport layer and on the control plane. So NMOS has specifications in it that define how you do interoperable, secure communication on the control plane. And also IPMX includes protocols for both HDCP, so content protection, interoperable content protection, and I'm going to forget the name of, I think it's PEP, right? Yep, thank you. We're using a lot of the same technologies that we use for HDCP to also support encryption for content for, interoperable encryption for the consumer. So if you want to protect, say like you're in a courtroom or something like that and you want to encrypt the content, that's part of IPMX as well. So IPMX, like SMPTE 2110, is either multicast or unicast. It's almost always set up as a multicast flow. It's also, I'll have another slide on this. We use elementary streams. One of my favorite things about IPMX is that it uses a lot of protocols that are old as dirt. So we're talking about UDP, RTC, or RTP, RTP sender reports. All those are things that IT people are familiar with. IPMX and SMPTE 2110, of course, just define how they're used in an interoperable way in AV over IP. One of the most interesting things about IPMX is that while it can and does take advantage of PTP, it also defines how to operate the system without PTP. And we've actually found that there's a lot of people very interested in using IPMX without any PTP in it. What's cool about it is that even without PTP, you're able to achieve subframe latency with IPMX. If you're just going point to point, it works just about as well without it. When you add PTP into it, you get fast switching and also, of course, the ability to handle synchronous sources as well. So we take advantage of PTP if it's there, but it's not required for those that don't want to go through that complexity. IPMX and, of course, SMPTE 2110, but IPMX is very, very much close to AES67. So, for example, if you have an AES67 source, that's going to be able to flow right into IPMX without any problem. Where the reverse direction might be true depends on if your video or your audio is synchronous or not. So if your video or if your audio is asynchronous, it's not going to be AES67 compatible, but we keep it very close to AES67 and also SMPTE 2110 because there's a lot of opportunities and a lot of use cases where people want to mix their live production and their presentation workflows. Also a part of IPMX, and this part is in progress right now, the USB KVM specification, but we do consider and are including on our roadmap all of those extra control protocols that we all have to work with, like extending serial, extending USB, and also CEC and GPIO are part of the IPMX roadmap as well. Yay, that worked. Yeah, so high-level differences between IPMX and other open standards, or other standards or other, I'll say, proprietary ecosystems in the market. You'll hear me say open, open, open in my presentation about 1 million times. It is probably the most important part of what we're doing. So I'm from Macnica. There's people from Matrox here. There's people from Altera or Nextera here. There's others that are part. There's 5 implementations of IPMX that are in progress right now. And, all of us working together to create a completely open standard not captured by any one manufacturer. So if any of you tried to buy a product that was based on a proprietary ecosystem during the pandemic supply chain issues, will know in a very personal way the advantages of an open standard. Another thing that's unique, and I've been talking about SMPTE 2110 and AES67 and IPMX and the relationship between them. That's a key advantage to IPMX. We know now, in enterprise and education, they're doing a tremendous amount of presentations like what we're doing here, but they're also doing a lot of live production and a lot of interactive workflows, right? So the ability for IPMX to work well in both of those environments is a huge advantage. Another thing that's a huge advantage about it is that if you do have a SMPTE 2110 system, now you're able to use the same control plane for both your live production and your presentation workflows. So that makes it a lot easier for companies to, to manage their video. It's just video on the network instead of having AV over IP, and then you also have something else, right? All right. Oh, shoot, how do I do? Well, that's okay. This last one is SDVOE. No, this last one is HD-based-T, which is not an IP-based, but we just have this simple chart here. Obviously, we're not including everything on here, but we just wanted to throw this up as comparison. Obviously, SMPTE 2110 and IPMX are very related. We have SDVOE over there. I guess I'll just highlight that, as I mentioned earlier, IPMX is not really tied to a bandwidth. So the standard is designed to work with 1 gig, 10 gig, 25 gig, multi-gig, 100 gig, just like SMPTE 2110 is. So that's one difference between them. And also that ability to work in that live production and presentation workflow is, by using PTP and being able to support synchronous sources is a big part of what we're up to as well. Oops. I'll just mention a thing about NDI. So NDI is extremely popular in the live production world. It's very, very successful. A lot of people doing great things with it. I'll just mention it here, but it's not really a direct comparison. It's not fair to directly compare them because NDI isn't really made for presentation workflows, right? So it doesn't have EDID. It doesn't have a lot of the things you would expect if you're doing a Pro AV workflow. Here's a high-level kind of stack here of what IPMX looks like. So at the bottom, we have, like I mentioned, very open, very well-understood protocols like RTP, RTCP, PTP, WebSockets, and HTTPS. This is really a part of the NMOS control layer. Any of the gigabits are supported, of course. And then on the transport side, we have the VRS TR10 documents that make up most of IPMX, that includes ancillary data like that SMPTE 2110-40. That's the kind that carries things like closed caption data. We also have forward error correction, which is also part of the suite of standards that we're bringing forward. And then we have our asynchronous control traffic as well, remembering that all of the flows are independent and independently routable and independently on the network. And then on the top, we have, I say RESTful. It's not really RESTful. It's an HTTP protocol, but it's that's NMOS. So that NMOS kind of is the application layer, right? And that's a real key thing about IPMX. To be an IPMX, you must have NMOS. So there's no such thing as just the control layer and then someone's proprietary control protocol, and that's IPMX. That's not IPMX. So IPMX includes both the transport and the control plane protocols. This is a bit of our roadmap here. I've checked off the boxes that that have been sort of those documents have been finalized here. It's a bit of an eye chart, so I'll make this available on video later, or you can talk more about what's on the roadmap and what's coming up. I think some of the key ones, one of them that I didn't really mention much about, and this is one of my favorite parts of IPMX because has anybody ever had any problems with EDID in the world? Yeah, anybody have their own war stories or scars on dealing with EDID? So in one of the things we did here, and it's on the dynamic connections on the far right over there, the NMOS IS11 is a really cool protocol that we've added to NMOS that basically allows for basically you to handle EDID-like issues, but over a multicast network. So the ability to take all these monitors, find what the constraint set is common between them, let the controller constrain that even further, and then tell the source device what its choices are. The source device says what it's going to flow, and then it makes the connection. And IPMX is actually supports even dynamic switching of resolutions. And as a user, if I'm on my laptop, I want to switch to a game, it switches the resolution. IPMX and the RTCP sender reports actually will advertise that change so that the display device can react to it. So in that way, it's acting like you would expect it to, like an HDMI cable. There's architectural details here that I included. I want to show these, but I'm going to go through them very quickly, and I want to invite you guys to ask any questions about them, and then I might actually pull someone else here if I get in and over my head. Some of this stuff is pretty detailed. I mentioned earlier, usually, there's two fundamental ways to do transport. There's the bundled method or the essence space, where each audio, video, and ancillary data and control data are separate. Of course, IPMX, as I mentioned, is the elementary flow. So that means that you can route, even you're taking your HDMI in, you go, through a gateway device, and you have your output, you can route your audio and video independently. This is a chart here. This was made by Wes. I've kind of struggled with this, and I probably should delete it, but this is kind of showing the timing architecture of IPMX. So here we have a common reference clock. We have IPMX senders and devices. They're all part of the same network, but you might have media devices, sources, and sinks that are asynchronous to that. IPMX handles that through RTCP sender reports. I think I got a slide on that. Yeah, well, I'll go back here. IPMX handles that. I'll go to this one here. There's kind of three timing modes that you can kind of think about with PTP or no PTP, synchronous sources or asynchronous sources. So the synchronous sources with PTP, that's actually SMPTE 2110. So an IPMX receiver, of course, will have no trouble operating in that mode because, if you think about it, synchronous is just a special case of asynchronous. So it's where the timing actually lines up. Asynchronous sources on PTP are also supported. What's nice about that is that you get very quick clock recovery. So you're on source A, you want to switch to source B, and you don't want to see any blanking there. If it's the same resolution, your monitor is going to go right to it. So it's possible to have very, very quick switching. And of course, then there's the no PTP case over here, where maybe a little bit longer clock recovery, maybe a little bit of a blank, in between switching, but of course, extremely easy to set up and very friendly for software-based solutions. So this is some of the timing synchronization. This is kind of a much more technical slide here, but yeah, I'm going to skip this one. So sorry, guys. This is talking a little bit about how things get aligned. We have if Jean were here, he could go through this, but basically you have sending devices that are sending packets out. We measure the delay between them, and then we allow you to basically realign at the source. So even though you might have sources that their PTP is present, but you have HDMI sources, and they're not resampling or resyncing things or time-based correcting anything, they're all going to have a little bit of a delay. And then there's also can be a network delay on down the chain. What's nice about IPMX is all of that timing information is included in the protocol, so you're able to at the receiving device, you're able to realign those sources, and even though they started with different timing, so it can reason about what the alignment is, even though they might be taking different network paths or different device paths. That's very, very handy for things like video walls or even live production. HDCP is a big deal. There's a lot of solutions out there that have HDCP. If you kind of dig into it, you kind of wonder, how did they do that and make it compliant? And maybe some of them aren't kind of technically compliant. Well, because we're an open standard, we absolutely had to have compliant HDCP. So we worked with the DCP. We even, went back and forth with them a few times on some of the requirements for AV over IP. And we came up with a totally compliant DCP or HDCP implementation that the DCP has blessed and approved. what was required of VidTrans, or I'm sorry, VidTrans, what was required of Video Services Forum, or VSF, to actually make it work in an interoperable ways, we had to come up with something that would allow for the key exchange between two devices that are made by different manufacturers to be able to do that key exchange. So what we did was we came up with something called HCAP. And HCAP is just the method by which two devices do that key exchange so that they can do that little handshake, and then they continue to do the handshake as it goes along. And we're able to achieve interoperable HDCP. In fact, you can see that here. This display here has a non-HDCP source. This is HDCP, and we have a presentation switcher that's taking those two and putting them together, and they're doing the key exchange from the source through the presentation switcher into the gateway box, and that's HDCP all the way through. There's more about this. If you want to ask questions about it, I'd be happy to answer them. Yeah, I mentioned about EDID earlier. Yeah, constraints on the set, so I'm kind of efficient on that one. So where are we at today? So the core documents for IPMX have passed their testing. So as I mentioned, the Video Services Forum does the transport layer. And just last week, we had 5 different manufacturers in Munich all working together to test the standards. So normally we go to these events and we test the implementations. At this event, our goal was, manufacturer A, they read the standard, they implemented. Manufacturer B, they did the same thing. Do they actually work? Or was there an interpretation that each of them made that ended up making it fail? Well, we've been working together so long and so hard, we kind of expected everything to work, and lo and behold, it did. And so we've had all green check boxes. That means that all of the core documents that define timing, that define transport, that define audio and video baseline standards are basically have all passed those tests. And the next step is right before VidTrans, which is later this month. It's now February, so later this month, we expect to have it ratified. So we'll look forward to that. If you want to take a QR code there, you can actually read those technical recommendations that are freely available on the VSF website for you to take a look at. So what is left? Is IPMX ready and finished? There's still a few things left to do. So we're finished enough where you can see a lot of implementations here. We've got a lot of excitement from vendors already selling IPMX ready products. But in order to actually have IPMX products on the market, we still have some definitions to do with our basically what we call the logo program. So how do I legally put IPMX logo on my product? How do I say my product supports IPMX? There's still some definition left there to do. That document will include, what every product must support. What are the performance and behavioral requirements of an IPMX device in terms of its transport? And we also have to do some finalization on the profiles. A profile is, if I have profile A on this device and profile A on this device, I know they will work, right? And so that's that uncompressed would be one profile. So if 2 uncompressed IPMX devices should work, defining those profiles is still part of it. And of course, a big part of IPMX will be the testing and certification requirements as well. We hope our target is to be completed with that document around InfoComm. That doesn't mean that we'll necessarily release at InfoComm, but that's kind of what our target is for that document. All right, well, thanks everybody. That's my my presentation. I hope I've left enough time for you guys to ask any questions you might have.